Okay. Just want to show you the time. Realize I've interrupted the flow of time by turning that off, and we've got a crucial piece of data right now I want to show you, which is the water bath, the water on the outpost. Not that it's crucial, but it's interesting. So, let me make sure you can see what we're doing here. I see what you're seeing. That should be about right. Now, I'm going to go ahead and pull this out of the top so it's out of the way because it's pretty cumbersome. And I'm going to go ahead and take this weight off because it's pretty cumbersome too. Hold on a second. Don't want that to drop. Fly and be free. Remember that from Work and Minnie? Minnie from Colorado? That's where I was born and raised. Now, it looks dry in there. That's the water. Oh, shoot. Okay, just went into the bag. Okay, there it is. So, here's the setup. And we had, that's all the water that was in there. We just drained into the bag. And we'll get that out of the bag. Probably should let it dry up a little bit. I'll take a towel and dry this off so that we don't get any external water outside of the bag into it. So he took a juice bottle, cut it out, put it around, he just cut out the end of the plumbing cap that we had on there before, so it was empty on the bottom, just for a rubber seal. Put that over, took a flame and melted it down so it was tight and snug around here, and then he put this clamp on there, snugged it up really tight, so this is nice and watertight down here. This is tightened up really tight here. This is, chemistry type of tubing that he's inserted into a small opening on the top so it's watertight and airtight. And same thing on this side. You've got a rubber band around the opening, and there's the water. That's what we collected on the back side, and we'll weigh that or measure that right now. I've noticed that I've not turned this so that the water will go up into the ceramic matrix to soak it up into there. So we've kept it nominally at no more than that angle. So it's either been this or this or less. I mean, this has been the most horizontal that it's been, about like that. And so no water has escaped up into the matrix or into the ceramic insulation. So I'm going to do this in 2 steps. Let's dry this off first. Hold on, let me go get our towel. I'm going to keep this inclined. Where's my... There we go. The airtight on the top was because this fitting was quite a bit smaller than the plastic tubing over the metal pipe, and so it was a fairly tight fit to squeeze that in there. We tested it multiple times, sitting in the water, blowing on it, making sure there wasn't any air escaping, and we never saw air escape from the top, only from the bottom. And we had a big leak, like I said the other day, a couple days ago, and that's when actually that was yesterday morning. I can't remember. Anyway, we dried it all out, like I said. So let's dry this off. we were painting the surface black with shoe polish so that see if we could get a better infrared reading on it when we were playing around a couple days ago. I guess that was yesterday actually. And I'm going to leave it at that incline. Try the tubing off. Move this over a little bit so you can see. Okay. Put the towel, set the water bag on there, and let's try this baby out. I'm going to keep that up. Right there. At least keep any dripping water off. Okay, that's nominally dried off. Now, there's a little bit of water in the cap, so I'm going to unscrew this over the beaker. The beaker is empty. I'm going to try that out too. So we will empty this out over the beaker. A little bit of water, maybe 10 milliliters. Okay, that is now empty. So it's got we put a O-ring in there so we can squeeze it down tight and get airtight seal. You see how big the rubber is compared to the opening to make it nice and airtight. And then let's take this off now. Have this rubber band tied on there. So undo that. So that's the rubber band we have tied on there. And then that's the fitting right there that we had. And there's our water. So we now take this bag and empty it. There's going to be a little bit of water that's going to be left over in this bag. And what we could do is, if we had an accurate scale, I don't think that was accurate enough that we've got here. We could take the, before reading them, we've got an empty bag, and we could take the dry bag reading and see what weight we have left just in the water that's stuck to the bag. It's really wet right there. What is that? Now, let's take the weight of this. I don't know how flat that is. It's 140 milliliters on the output. And we had 213 going in. Not the same ratios we had before. We had 21% before water on the output side versus the input side. But I don't know if this is going to be. I got like 15 bags from the grocery store, expecting that we were going to get a lot of gas on the output side. I was not expecting that we would get no gas, essentially zero gas on the output. Oh man, this thing's just not going to weigh that, not at all. Doesn't even register. So, anyway, make a guess estimate. What I could do is I'll freeze this in the freezer, and I'll have Daryl get that measurement for us for something more accurate. Okay, it's in the freezer. There's the trailer hitch we had. We're going to have to, we didn't take that into consideration yet in the 77% that we got. That's going to be absorbing some of the heat, and it could be part of the caloric heat loss that we didn't tabulate. So we need that's 2.25 pounds. I'm just going to, yeah. I concur. So 2.25 pounds trailer hitch. And then there's the steel tub that we didn't take into consideration. And the heat into the environment, even though it was insulated, it wasn't perfectly insulated. And our cool down readings will give us that information. So another thing too that's really cool is that when Daryl last night got up at like 2:50 or something like that in the morning, and he came and he took a temperature reading, and it was the same reading as the last reading we took at 9:21 when we stopped the reaction. And so apparently the residual heat in the catalytic converter, I guess, put more energy into the water bath because there was a delta T there. It was still hotter than the water bath. So that heated it up some more. And there may have been a continued reaction going on. We've got a couple of data points. We'll be able to tell from the data. There's a small possibility that he took the reading wrong. So we'll be able to tell from the other data points, if they go into a nominal curve, if they fit, whether or not that's the case. But that's really interesting, because to keep that water bath at the same temperature 5.5 hours later almost, when once it started dropping, it was going down like 1 degree every 2 hours. So just another heat source, or another tabulation to take into consideration on the output end of this equation. See if there's anything else I need to mention. I think we're done. Time to clean up. Want to see those meters again? Still climbing. Climbing quite rapidly. Look at that. Going crazy. That is wild. Yeah. So how do you measure resistance without creating electrolysis? That's the question. Oh. And changing the resistance by doing so. Okay, one more thing. Just forgot something. We tabulated. I did put 42 liters into the tub, but that leak happened before our test. And so what we just measured emptying the tub, we'll go with that number because that's the number we are actually measuring. And so we'll go with I just calculated 41.605 milliliters, plus or minus 20, or like 0.02, I mean. So that will be the volume of water that we'll go with that we were heating, okay? Okay, Daryl just got back from his festivities of the day, and we're going to take the cap off of the catalyzer and see how dry it shouldn't be wet in there, so it doesn't matter if you tip it.
It's not as bad as it was last time,
damp.
but it's damp. It's definitely.
Let's measure that because that's going to be steam or water. It'll be part of our output equation. So let's measure. If you could do your accurate measurement on that and on the bag, it is damp.
Yeah, definitely.
Probably from the gas reaction. Yeah, that one's damp too.
Still is.
That one almost feels wetter.
It's getting drier as we go down.
That one's wetter.
Yeah.
Huh.
It's getting drier as we go down.
It may be. Huh.
I think that some steam must be coming from the generator with the Brown's gas and condensing.
You can see it's kind of soaked on the edge there.
Yeah.
Yeah, you can see water on the bottom there.
Yeah, around
Yeah.
on the edge.
Yeah, we'll definitely want to measure that. Yeah, look how that's almost sopping wet right there.
Okay.
So okay.
Do you want to take this out?
Yeah, we could take it out and measure, but let's get your. We'll want to measure the wet and then measure it dry after it dries up. So we'll need to have a scale that's fairly accurate, but that's somewhat heavy. But let's put these back in. Do you have your scale handy that can do the accurate measurements of the weight?
It's. I could go get it.
Yeah.
It's over.
It's over at the, okay.
Yeah.
I'll wait for you.
Okay.
Let's tear it out.
0.0 grams on the scale.
$89.3 grams. Okay.
Okay.
Now let's weigh the bags in the freezer. Okay. We'll take this off because this is empty.
Oh, that's your empty.
Yeah. So that's 11.0 grams. Hold on. So here's the dry bag. Just making sure we have this recorded. And here's the wet cat. 670.4. Fly and be free. Remember that from working Minnie? Minnie from Colorado? That's where I was born and raised. Now, it looks dry in there. That's the water. Oh, shoot. Okay, just went into the bag. Realized I'd interrupted the flow of time by turning that off, and we've got a crucial piece of data right now I want to show you, which is the water valve. The water on the outpost. Not that it's crucial, but it's interesting. So, let me make sure you can see what we're doing here. I see what you're seeing. Okay, just want to show you the time. Okay, there it is. So here's the setup, and we had that's all the water that was in there. We just drained into the bag, and we'll get that out of the bag. Probably should let it dry up a little bit. I'll take a towel and dry this off so that we don't get any. That should be about right. Now, I'm going to go ahead and pull this out of the top so it's out of the way because it's pretty cumbersome. And I'm going to go ahead and take this weight off because it's pretty cumbersome too. Hold on a second. Don't want that to drop.